Ever wonder what really makes something burn? It's all about combustion, which is just a fancy term for the chemical process that gets things igniting. So, what do you need for this fiery reaction to happen? There are three key ingredients: fuel, an oxidant, and a bit of heat. Pretty simple, right? And here's something cool: every fuel has a flashpoint. That's the minimum temperature it needs to reach before it starts giving off enough vapor to catch fire and burn. So, next time you see a flame, just remember, it's all about that perfect mix of elements coming together to create some serious heat. But you might still be wondering, what exactly causes that ignition? What provides the initial heat needed to start the whole thing? Well, it turns out that almost anything can burn if you provide the right conditions. Let us take a look at how some everyday items burn and the science behind why they burn so well. Butane is a great example because it's already in liquid form at room temperature. At a microscopic level, that liquid is made up of molecules that are held together by weak bonds. When you apply heat, those bonds break and the molecules turn into a gas. That process is called vaporization or evaporation. So when you turn on a stove burner, you're heating the butane and providing enough energy for those bonds to break. Butane becomes a gas and mixes with oxygen from the air. Then when the gas reaches its flashpoint, the heat from the stove is enough to ignite the butane, causing the flame, you see? Now, butane isn't the only fuel that burns like this. Natural gas, which is mostly methane, does the same thing. That's why you can light a gas stove with a match or a lighter, but some fuels need a little help getting to their flashpoint. Propane, for example, has a higher flashpoint than butane, so you can't easily ignite it with a simple flame. Instead, it needs a spark. This is why a propane grill uses a spark igniter to create the initial burst of energy needed to start the gas. And not all fuels are gases at room temperature. Wood, for example, is solid at room temperature. But once you start heating it, say with a match, the molecules within the wood absorb energy and vibrate faster. As they move more quickly, the bonds between them start to break, turning the solid into a gas. Once it's reached its flashpoint, the hot surface of the match ignites the vapors. But wood is a more complex fuel source than a simple hydrocarbon like butane. It contains compounds made of hydrogen, carbon, and oxygen, which means that, in addition to producing flammable vapor, burning wood also produces flammable gases like hydrogen and methane. This is why a forest fire spreads so quickly. All those trees are basically just giant torches passing the flame to each other. But wait, not all fires need a flammable gas. Some only need a little hot surface. A classic example is magnesium. This silvery white metal doesn't look particularly reactive, but when you heat it, it reacts vigorously with oxygen in the air. If you heat it enough to reach its ignition point, you'll see a bright white flame. That's because the reaction between magnesium and oxygen releases so much energy that it actually causes the magnesium to burn. And that burning magnesium gives off so much light that it's used in some emergency flares. So whether it's a metal, a hydrocarbon, or something in between, almost anything can burn given the right conditions. Just remember that whatever fuel you're dealing with, it takes a hot surface to produce a flame, even if that hot surface is produced by a tiny spark.